Hello everybody, Brandon Young here, and we're going to dive right into our Lab 1. So here we go in our pre-lab. We're going to see right now this table of S, A, and B for our 2x1 multiplexer gate. And here we already see our outputs, A.S bar and B.S. So these are two we combine together, and that's what we're going to use to get our readouts. As well as below, a chart I wrote up for the AND, NOT, and OR gates. So we're going to scroll down, we're going to check to make sure these are accurate with each other. So first up is our NOT gate. As you can tell here, we have a 5 and 5, our A and B's, as you can say. That's giving us a low output. That's what the 61.2 millivolts is referring to. So this is a low output for our NOT. So if we scroll up to our NOT sketch here, we should see that as well, being within its limits. Exactly right. So we should be able to see our outputs are right, in fact, in line with it. So we can take this and continue forward to our AND gate. We add on a transistor in order to make sure that we are currently, obeying our laws here. So right now we have, in this case, our outputs, our inputs are going to be A and B here, V1, V2, 5 volt and 0 volt, giving us a reading of 0 volts. So 5 and 0 at our AND gate, giving a 0. Therefore, if we go back up here, we should be able to say 5 and 0 and a 0 volt, exactly right. So we're already on the right track. So then if we go one further and we go to our OR gate, we should be able to see that this is giving us a 0 and a 5 volt reading. So that would be our first and second impulse. And then we're getting a 4.21 volts, which essentially means a high reading. So when we go back, high reading. So we go back up to our OR, we should be able to see, yes, exactly right. We should be able to see it up here that we're getting a high reading indicative, down here, of our correct platform. So now, if we head a little bit deeper, we're going to have our 2x1 multiplexer gate. Now notice here that we have a 5 and a 0 volts for our A and B, as well as an S of 5 volts. So if we am getting an output of 0 volts. So if we go back up to our first setting, up the top, all the way, scrolling all the way up here, if we go back up here, we'll notice this is actually in line with what we have on our chart, telling us that this is also, once again, obeying our expectation in a truth table. So now we're going to go one more time, all the way back down here, all the way down. We're going to go here to our diagram. Now this is stolen right from Tinkercad, created from Tinkercad. And forgive me on this one, I sort of wired them a bit upside down. But basically we have our AND gate on the far right, we have our OR gate in the center, and we have our NOT gate on the far left, our inverter. So that is the AND on the right, not in the center, OR in the center, and NOT on the far left. So when we look at these guys, we should already be able to see this should be fitting our multiplexer idea. So if we scroll one more further down to number 5, here we have our 4x1 multiplexer, combining these two ideas together. So now that we have all this set up, we can dive right into the lab itself. Alright, so let's dive right into the lab itself. Alright, so I'm a mechie, so that means I have to do some mechanical solutions, so forgive that, no one else is free. So now in order to check our circuit, we're going to now move up our values. Right now, A, B, and S are all in the high state, and LED is on. So now I'm going to move our A down to low, and I'm going to move our B down to low. Come on, B down to low, and now we're getting nothing. So now if I were to move our A back to the high, what are we going to get? Also nothing. So this now corresponds very closely, we can sort of see a pattern of how it's going to correspond with our table given in the pre-lab. So now we're going to start moving to the third part of our lab. Alright, so now here we have our circuit. So right now if you look at it, our LED is flashing rather rapidly, close to the 10 Hertz we should expect, on the high setting. And here's how I look at the Arduino. So now if we go back up here to our code, we should be able to see that that high is coming from the 4, our digital input of 4. And so when we look at our code, it makes sense. So now if we had flipped this a little bit and we try to move this to low, it's much, much slower, which totally goes in line with what we want to see before in our code. So thanks again for the help. Remember to like, comment, subscribe, and tune in for more videos in the future.